have functions, sometimes we may not necessarily know what the function is, the equation is. They may just represent the function with the graph. And if we do that, a lot of times they say, well, this is y equals f of x, just to kind of give it a generic name. We could call it g of x or some other name there. But in this particular case, this is our function. Like I said, the high point there is at 4, 5, and then it ends up at 6, 3. Is the end point. Yeah, and so this is different than the other functions we were talking about earlier, because this actually, we've kind of limited our domain. Sometimes they will limit our domain, whereas usually we're just saying, well, you can go out to infinity or negative infinity. Sometimes they do limit here. And so the domain, we just read it right off the graph here. The domain are the x values. So they come off the x-axis, if you will. And in this particular case, the x values, yeah, I don't go out to infinity or negative infinity. I just go from here to here, don't I? 0 to 6, and including 0, including 6. So, yeah, if they've got it shortened, if you will, truncated, whatever the word you want to use there, like that they want you to say, well, the domain's just where those x's run from. Okay? The range, same thing. The range here will be the y, the output values. And so in this case, the output values, we have a limited output here too. What do the output values, the range values look like? Well, coverage-wise on the y-axis here, I don't have anything below 1. And this is at 5, so I don't have anything above 5. So isn't the range 1 to 5? Would you say that? And so that's how you kind of read these particular graphs as far as domain and range. And then they could ask you the function values. You just have to read them off the graph. It says f of 4, again, that's our input value, or x value. Just wants the y value that goes with it, right? So f of 4, so x is 4, so the y value is 5. So same drill, you just don't have a function to put it in, equation per se, you just have to use the graph. Any questions or concerns there? Okay, now another feature about this, and I guess I could do it here. Another thing they'll ask here about is where's your function increasing, where's your function decreasing? And as far as right now, all we're concerned about is just looking at the graphing perspective here. And it's pretty easy if you got the graph to locate increasing and decreasing. Basically what increasing means graph-wise is if you're going left to right, so if I go left to right on this graph here, this thing is increasing starting at 0. It's going up, in other words, I'm looking for increasing. If it's going up from left to right, that means the function's increasing, and then down, if it's going downwards, that would be decreasing. So fairly easy, going left to right. Speaking of here, and the reason that's the way it works is because what they're saying is, if I go from 0 to 1, the function value goes from 1 up to about 3, it looks like. So the function value is increasing. So we're talking about increasing function value and decreasing function value. So that's why that works. Up, left to right means you're increasing. down left to right means you're decreasing. Now, one thing here, and we'll talk a lot more about this and explain more about this also in a few days down the line. So we would say, and what we use is we use the x-axis intervals. And so it's increasing, yeah, it increases from 1 to 3, but we use, 1 to, the function values go from 1 to 3, but we actually use the y values here. We use the x values, take 2 again, take 3. We use the x-axis values to describe where it's increasing. So it's increasing on 0 to 4. Now, a little disclaimer here. Technically, we would call that 0 to 4 with parentheses included, not including the endpoints. However, the book, in this particular section, I don't know why, they're going to probably put including the endpoints, but I'll explain later on why that's not quite accurate. Should I say that about the book? Anyway. So if you use either one, you're okay here. And so it'd be decreasing, what, 4 to 6? I don't know what else happens. After that, and so, all right. Now, let me do one more of those before the increasing and decreasing. All right, so just kind of drawing along here. We'll probably have a nice long one for you on these increasing and decreasing. So that's point A, point B peaks out here, C peaks out there, D up here. Looks like I want to call it A1, B's at 3, C's in between 5 and 6, and D so A is above 1, B is above 3, C is actually halfway there between 5 and 6, and then D is right above the 8. Keep playing along there. I have a handout to show you. Okay, so let's come up, where's this one increasing? Where's this one decreasing? Well, there's multiple parts for decreasing and increasing here, isn't it? And right now, we're just looking at it, how's the graph progressing as you go from left to right. Now we'll talk about this over here before A. We're not doing anything before A, are we? We're not going increasing, we're not going decreasing, we're just kind of staying flat. More about that in a second. Once we get A and then go to B, yeah, we're going upwards, so that's increasing, and then B to C, we're decreasing because we're downwards. C to D, all right, we're going back up, and then D on out. Looks like it's decreasing. So this one's not limited. We're going both directions infinitely. So, all right, so our increasing, yeah, we've got two parts that are increasing. We use the x-axis here to describe it, the location of it. So where would we say this one's increasing? 1 to 3. And again, I would like for you to put parentheses. The book uses the square brackets, but I will use the parentheses, and then where else? So this one, all right, so C starts our increasing point for the graph, and then C to D, so that would be about 5.5 to 8. So there's two parts, and you know, whenever you have two parts like that, what you'll usually see is that union symbol between them. So kind of connect them. Is that okay? Good on that? All right, then the decreasing, okay, so decreasing, well, it's decreasing in between here and here, so that's 3 to 5.5. And then, all right, so what about the other part decreasing? Well, it's 8, and then it goes down from there. However, in the x-axis, we're going from 8 out this way. I mean, the graph goes down, but as far as where we're going from 8, we're going out that way. So that's 8 to infinity. That's where it's decreasing.
Negative infinity.
Well, it goes down to negative infinity, but as far as the x-axis goes, we're going out to positive. The y values are going to negative infinity, but the x values are going out to infinity, you see. So that is a little confusing. You gotta keep that straight. We're going this way on the x. We're going this way on the y, which is negative infinity. You know, we're going this way, which is positive. Yeah, you're doing the x values.
Yeah.
All right. Now, before the a, all right, so it's not increasing or decreasing here. It's flat. So, yeah, that would be considered constant. I don't think they ask you where's the graph constant, but just FYI, we call that constant, function constant there, because it's not changing either one direction or the other. It's staying flat. All right. Oh, yeah. So if they give you then this task, all right, where is f increasing and decreasing, and f is x squared plus 6x plus 9. Well, right now, let's just look at the graph, okay? Graph this out via calculator, via manually. You want that practice, do it by hand. You may have an idea, it's a parabola, right? You know that. Get the various points, but graph-wise, all right, so, oh, yeah. Comes out right here. Vertex-wise is right on the x-axis. Yeah, so the way we're doing it right now, just graph it out, find the increasing and decreasing parts. So easy enough. Yeah, we see, let's get down here, so that's decreasing, turns around and goes increasing at -3. So it's increasing on -3 to infinity. And decreasing, yeah, so it comes out from infinity out here, but again, we're talking x values here, so the interval comes in from the x, what's out here for the x? This is negative infinity, isn't it? So you're going from negative infinity to -3 for decreasing. Fall, that would be blooper highlights. All right. Good with that?